Hey, what's going on, people? Thanks for joining me for another spellbinding episode of Making Yourself Mental with Arduino. Today's episode is going to be about Lora. And if you haven't heard of Lora, I'm going to try and explain a little bit about it. And then you're going to want to fact check everything I say because basically I'm an idiot and I'm just feeling my way in the dark here. So here's how the story goes. I've got this neighbor who's got this huge golden retriever. And it likes to run away. Not because it's not on leash or anything, it's because when it sees a deer or a rabbit or something, it'd sooner tear your arm off than let that thing go. So that's what happens. And then it gets lost and everybody goes out and looks for it, and it happens on a regular basis. So I thought I could help the guy out by setting up some sort of GPS tracker for this dog so at least have some idea where the thing was. Now, I know you can buy these things right off the shelf, but here's the problem with that. You got to sign up for a data plan, which means you're paying every month for data for your dog. And that, to me, seems crazy. Now, at the same time, on Hackaday, every second article seemed to be about Lora. Lora, all the time. So I kind of got sick of not knowing what the hell that was and looked it up. And here's what I found out.
Lora is just a radio for the Internet of Things. For example, it'll allow your toilet to talk to your refrigerator and tell it when it needs to order more corn. It's similar to your Wi-Fi router or Bluetooth with some pretty important distinctions. First of all, it runs in a free frequency band, which in North America is 915 megahertz. So you don't need a license to set one of these things up. It also operates at super low power levels, which is great for running things on batteries. And it has a much larger range compared to something like Wi-Fi or Bluetooth.
So this is it. This is an RFM95 Lora Module, and it is fucking tiny. I was shocked when this came in the mail and saw how small it was. So this is a transceiver, sends and receives radio signals. The only downside to this is the data rate is low. So if you think you're going to send pictures or music through this thing, it's not going to happen. It's got about the same data rate as a first generation modem, if you can remember back that far, which sadly I can. So you're looking at data rates around, or less than really, 300 bits per second. So that's pretty slow, but all this is really being used for is sending sensor data, or GPS data in our case. So it doesn't really matter that it's got such a low bandwidth. So if you've seen any of my other projects, you'll know that I really like a detailed plan before I get into things. So here we have our dog chasing squirrel, and on his collar he's going to have this homemade GPS tracker, which consists of a GPS module, an Arduino, and a Lora module to make everything work together. And then that Lora module is going to send information over to the top of my house, which will have a receiving module, a receiving Lora module, and be connected to a ESP32. And the reason it's connected to that is because that has Wi-Fi on it, so it will connect to my home Wi-Fi network. We would read the GPS location on the computer, map it, run out the door, and get the dog. You can see that the spacing for these pins headers is really tight. And regular pins that you have in your junk drawer are not going to fit this. So there's a way around that. So what you can do is you can get one of these ESP32 adapter boards and then surface mount the Lora module onto that. You have to remove these resistors, otherwise it won't worky. So I'm going to do that first, and we'll get some header pins on this Lora board. Alright, so that went okay, but something you should note, if you set this thing up like this, chip in that direction and your adapter board like this, this pin, which is supposed to be ground, according to the, diagram, this is supposed to be ground, but it's dead. So just ignore that one. Fortunately, there are two other grounds, one here and one there, so you got enough grounds to play with, but now pin no worky.
So I'm going to start by making that thing on the roof. It's called a gateway. In this case, it's a single channel gateway. Nothing fancy. And as with most electronics projects these days, it involves plugging together Lego bits until you get something that works. This is basically what we're going for here. These are the connections you need to make between your ESP32 development board and the Lora module. I'll throw the links down below.
Alright, got it wired up, easy peasy, just like the diagram. We're going to throw some code on here and see what happens. Oh, before I forget, always hook up an antenna to this thing before you try and throw any power through it, because if you don't have an antenna on it, I guess it feeds back on itself, heats up, could blow up your chip. So, yep, there's that. So with a little bit of code on here, this seems to be working, but I won't really know until I actually send some data to it. So I'm going to make a small node out of this Arduino Pro Mini and our other Lora chip. So I'll do that and then we'll check it out. So after a bit of dicking around and double checking connections, I think we've got her going. This is the gateway. And this is the node. So this is sending signals, this is receiving signals. These are antennas for each of the little Lora modules here. And we go over to the big board. Look at that, eh? It is actually receiving packets. This is the gateway monitor. The node just continually sends a hello packet every 10 seconds or something like that. And there it gets picked up right away. So we're in business. So I think now I should just probably portify the node. That's not really a word, is it? Portify? Whatever. And then we can move around with it a bit and see what kind of range we're getting. This little electronic abortion is the portified Lora node, and I'll just give you a little quick tour of it here. This is the GPS module. It's Neo 6M. It works pretty good, actually. A little slow to pick up the signal sometimes, but not too bad. Anyway, the information from that gets sent to the Arduino Pro Mini, and the Arduino Pro Mini sends that through this Lora chip out through the antenna. Now this little guy here is just to charge this 100 milliamp 3.7 volt battery, which is directly hooked onto the Arduino Pro Mini and actually powers the rest of the stuff too. So actually I was quite surprised. This lasts quite a while, all things considered. I thought for sure I'd need to use a much larger battery, but it seems like I can get maybe almost an hour out of it before it dies. I haven't actually had it die on me, so pretty damn good. I have other batteries coming because I thought for sure this wasn't going to do it, but it's pretty tiny, so I might keep it. Other than that, oh, switch, power on and power off, and of course the antenna, which is just a piece of wire, and it's 78 millimeters long, which is the specification for 915 megahertz, which is what this chip runs at, or signals out at. And you know, if you have a different chip with a different frequency, you're going to need a different size antenna. Now, okay, so because this looks crazy, I have also a box which I will put it in, which is this, and I'm actually not going to even cover the box. I'm just going to put a rubber band around it just to keep everything in place, and then go do some range testing. So that'll be next, and I'll be back with some of the results. So I took my breadboarded gateway, threw it up on the roof, high as I could get it. And then with the transmitter, I just walked around the neighborhood and collected all the GPS data that was being sent to it, and then had a look at where those points were, and it looks like I'm getting about 500 meters of range out of this, which is not too bad considering I was counting on about 0. I was expecting it wasn't going to work at all, but holy crap, 500 meters ain't bad. So the 500 meter radius for this seems pretty decent for tracking a dog, provided it hasn't gone too far. So in this area right here, we've got some woods, and it shouldn't be too bad for just at least getting a track on which way the dog went and where it was last seen. So I think this is actually going to work. So since our last little chat, I managed to get my ass kicked by a plant, and I lost pretty bad. I got a good case of the poison ivies, and this isn't just the half of it. Man, I got it all over. Legs, chest, holy mackerel. Itchy, itchy, itchy. So anyway, it gave me some time to just work on something where I didn't move too much. So I've liberated the gateway from the breadboard, and we've got it hooked up to a battery. It's 18650, 4000 milliamp hours, although I don't buy that. Maybe it is. And it's sitting on a charge controller, which is kind of cool. Normally it would have a USB out here so you could plug it into your phone or whatever. But I took that off just to save a little space. And the input was here. You can see the input was a micro USB control port to charge it. So I've just hooked up some wires to that as my input now. And I'm gonna charge this thing with solar panels. Yes, we're gonna make this thing autonomous so I can stick it on my roof and not think about it again. So I think this is gonna work out. I gotta have to do some tests on how long this will last and you know, that kind of stuff. But I think we're along the right track. Now, weatherproofing this thing is another issue because it is gonna be on the roof, right? So I have these caps for this cheap ass drain pipe stuff you can buy at Home Depot. You get a huge length of it for like, I don't know what it is, 10 bucks or something. Anyway, pretty useful stuff. So I'll encase it in this cap on cap on the top and cap on the bottom, and seal it up and stick it on a pole maybe, or just jam it on the roof for now. And hopefully that will keep this thing safe. So that's what I'm doing next. I'm gonna put the battery thing in the bottom here, and then so I'm making these little standoffs to make a platform for this guy. So here's what I've gone and done. There's the battery, and I've attached that to a connector on the inside here, so it exposes to the outside. Should be watertight, I think. That goes in first, and then the tray sits on top of that. And these dowels fit precisely in those holes as a matter of coincidence, not because I'm smart. There we go. Okay, there's a little switch to turn it on. Here's that drain pipe. Had a little cutout there because of the power thing. So what we can do is just slide this over top and sneak it down into there. So that's how it looks like inside, and then the antenna is fully protected, which is good. Top cap. Solar panels wired in parallel because they're both 6 volts, which is what we want. I'll stick those on there, and then the little connector into the side. And that should keep that battery charged up. I've decided I'm going to try and stick this on a pole. This is an end for electrical conduit, you know, like your metal pole that you run electrical wire through. Anyway, it comes with a little screw end. You put the pole in there and run your wire through it. But it fits nicely on here, and that's the kind of pole I'm going to be using, so it seems to work fairly well. Battery in, and we'll go battery in, that on top. Cap it off with the solar panels, which are just adhesive onto the cap, and that should be the end of it. So here I am installing the pole holder thing for the roof. It raises the thing up another 6-8 feet maybe, which is pretty damn good. And so all I've got there is a PVC pipe, and you see there's a little bolt in the bottom to keep the other pipe from falling through, and then just clamp to it with some, whatever those clamps are, pipe clamps. It seems pretty sturdy enough. That thing's pretty light, so it shouldn't be too much of an issue. Of course, those poles come bigger, so I'm definitely going to be getting a bigger pole. That doesn't seem right. Maybe I should fix that.
You might be wondering how I managed to get the data from the thing on the roof down to my computer here, and I'll give you a brief explanation of that. Now, as I mentioned before, the thing on the roof has an ESP32 which connects to my Wi-Fi network, and then I can use a socket to monitor the data that's coming out of that. So I've written a little Python program that just continually scans that port and then outputs the data to the screen. So right now it is asleep, and I'll turn on the transmitter so that it should start receiving some data, and you'll see that it, well, eventually will actually, it's going to be a while. So what you're seeing here is the receiver asleep, and the reason that is because I want to try and conserve as much battery power as I can. it will cycle on and off between looking for packets and sleeping. And in this case, it sleeps for 5 minutes and then wakes up. But if it does detect something, then it'll go into a continuous read loop and until it loses that signal, and then it kind of tapers off, you know, keeps checking every once in a while to make sure that that actually signal is gone. And then if it really is gone, then it goes into the deep sleep for 5 minutes cycle again. So we're going to have to wait for it to come back out of sleep before we get anything out of it. So there you can see it there. It's relaying the GPS data. Then on the Python side, once it receives that information, it rewrites a web page inserting those coordinates into the mapping application. And then what you end up with is something that looks like this, which is like a flight path or a trail that's been created for those coordinates. So it's pretty slick, actually, and you can just look this up on the internets and it'll show you where your dog is. So with my gateway up on the roof there, on the pole, I'm getting about 700 meters of distance out of that, which I think is pretty damn good. Now, you gotta remember, this is a line of sight radio, so anything that comes between the node and the gateway is gonna decrease your signal strength. So houses, a few houses doesn't seem to make too much of a difference if you're close enough, but you get a big pile of dirt like a hill that you gotta go through, then you've got a problem. Now, they say the size of your pole doesn't matter, but I say the bigger the better. So that's about it for this video. I am not done with this project, although I do have a basic working framework now. Things to do yet are to put a better antenna up there. So just using these little wires is fine, but I think if we actually had a proper antenna, we might actually get some even better range out of this thing. So I'm going to try that. Also, this really needs to be miniaturized so that you can stick it on your dog. So I'll be working on that as well. Software wise, it would be nice to have it run on an Android app as opposed to just a web page, but either way, it's fine, I think. I may not end up doing that. And I'd like to switch from Google Maps to OpenStreetMaps, but that's another ball of shit altogether. So, we're gonna call it quits here. Thanks for watching, and we'll see you later. Cheers.